Today's DMT Insight is on ratio tables and how ratio tables can be used to build multiplicative thinking, whatever that is, all the way up to understanding of slope, whatever that is. Okay, so as a former algebra teacher 30 years ago and to today, we're still frustrated with kids not knowing their multiplication facts, not being able to use them with division, whole numbers, decimals, fractions, understanding ratio proportion, and slope in algebra. So huge problem, and one of the most undeveloped tools that we have in curriculum is the ratio table. So what is it? Why is it so important? That's what we're going to hit today. Okay, so how do you build multiplicative thinking? What does that even mean? So sometimes we have to practice even saying that word, multiplicative. So it means anything that you're going to multiply. So, and when you say multiply, it also means division. It's its inverse operation too. So we want kids to not only know procedures, algorithms, and facts, that's always important, but we also want them to reason and problem solve with them. So how do we start this process? So if we're going to go back to really end of second grade or early third grade, we want kids to start thinking about multiplication. And so one of the first things we're going to do is we're going to use a visual model. Now you can enact this out with paper strips before, that's awesome. But if we're imagining the bar model, just initially, if the fact 7 times 4. So what that means is, so 7, the multiplier, times the multiplicand, usually it's the iteration, the copies of some type of unit. So we're thinking 7 copies of 4. Now I know commutative property, we can talk about that, 4 times 7. But if we're thinking that initially, we're thinking, I want to do 7 4s. So we have the bar model, and so now we're getting a visual representation. So we're getting proportion, visual proportion, which is so critical, and that's the missing element. Check out our DMT Insight on enactive, iconic, and symbolic, and how important that is from Jerome Bruner starting in the 1960s, and why we miss that iconic piece all the time, which is the most powerful. Okay, so now we start, initially kids will say, okay, there's 1 4, 2 4s is 8, 3 is 12, 4 is 16, 5 is 20. So they're doing that just one after another, and that's great, getting that understanding. Now at the same time, I'm going to introduce the ratio table. So the ratio table, as far as I understand, I was working with the Freudenthal Institute in the Netherlands back in the mid-90s. And my understanding is that Freudenthal, the mathematician, and then some of the math educators, Grafenmeyer and Treffers, amazing minds in math education, started using a table to represent multiplicative relationships. So instead of doing the common t-table that's vertical, they did it horizontally. So horizontal to them meant it's always going to be in proportion. And if you don't know some of these ideas, I'll hit them here today as well. So what they're doing is now in the table format, which is not, it's a symbolic representation, not iconic, and they start representing the 1 to 4, 2 to 8, 3, 12, and they have that relationship. So once you get to 5, what we don't want to be building out is every single one of them all the way to 7. We want to start using it flexibly. So once we get to maybe 4, so we see 4 4s is 16. And then I'm looking, I see 3 of them right there in the bar model are 12. So if I extend on 3 4s here, I now have 7 of them. So then my ratio table, I'm looking at, oh, 4 4s here is 16. 3 4s is 12. I can put those two ratios together just like I did in the visual model, and now I have 7 4s is 28. So now I'm composing using different ratios. That starts building flexibility, which starts getting students to be more flexible in their thinking and more fluent overall. That's going to open up tons of doors in the rest of mathematics all the way up to slope. Okay, so now in third grade, as I was saying, a lot of times teachers are having them just do one at a time. That's great. Now we're going to start being more flexible. So by the end of third grade, and especially by fourth grade, with whole numbers, we want to start using what we call the 1, 2, 5, 10 table. It's really effective. So now instead of just building out 1, 2, 3, 4, 5, we're just going to use 1, 2, 5, and 10 to get a base start, and then we're going to start looking for combinations of facts we know that we can put together to build out our products. So let's do an example with 8. So we're going to have the students first build a 1, 2, 5, 10 table. So how I tend to do it is I say I have 1 8, I double it, so 2 8s is 16. I put the 5, I hold it for a sec, I go to the 10. So 10 times 8 is 80. Now, and again, just when you're thinking about multiplying by tens, think about changing place value, not shifting the decimal, not adding zeros. So we're going to get away from that. So it is increasing the 8 ones it's increasing it to 8/10. We're increasing by 1 place value. That's what multiplying by 10 means. Or if it's 100, we're increasing by 2 place values from 8 ones to 8 hundreds. That's a really important distinction that you can read in one of our other DMT insights. So now that we have 10 times 8, now what I'm going to do to get the 5 is from 10 to 5, we're not thinking additive. We don't want to add these, so the difference of 10 to 5 is 5. We want to think about multiplying, dividing. So to get from 10 to 5, I'm going to divide by 2. And so now I'm going to take that 80, I'm going to divide 80 by 2, and that is 40. So 5 is to 40. 5 eighths is 40. Okay, now I can say, okay, well, what about like 12 times 8? Now I look at my table and I say, oh, well, I already know, because I want to compose 12. I see a 10, which is 80. I already see 2 is 16. I can put the 80 and 16 together and get 96. And the numbers usually are really good. So now I have 12 times 8. So now let's go back to the other. I might say, I want 1,000 times 8. So same ideas. I have 1 8, I have 10 is 80. So now I'm going to multiply that 10 times 100 to get 1,000. So the 80 times 100 to get 8,000. Now we can also do that if we're thinking decimals, we can do the inverse. So what happens if I have that 1 to 8 relationship, but I want to multiply it times 100th. So now I can see I have 1 8, I can see I have 1/10 divided by 10, divide 8 by 10, I'm at 8/10, divide the 10th, I'm at 100th by 10, divide the 8/10 by 10, and now I'm at 800ths. So you see the relationship both ways. And so now it makes the mathematics so much clearer for us as the teachers and for kids. And once they understand it, they have less problems in the classroom, they don't act out as much, and they really do much better in the mathematics. Okay, let's do another example. So these were nice because I had 1. So what if we have, so now we're building up maybe 4th and 5th grade, we're dealing with decimals, we're doing powers of 10, all that's good. We're starting to approach 6th and 7th grade where we're doing proportion, percents, and slope. Okay, so now I was traveling and I saw a really amazing orange juice recipe. I thought it was just made with oranges, but no. They had the ratio of 2 grapefruits to 5 oranges. Actually try it, it's absolutely awesome. Okay, so now we have this ratio of 2 to 5. So remember I said I wanted that 1, 2, 5, 10 table. So now I already have the 2 to 5. So I'm going to back up, I'm going to divide 2 grapefruits, I'm going to divide by 2 to get 1, and I'm going to divide the 5 by 2, which gives me 5 halves, or 2 and 5/10. Okay, that's important. Okay, now I could take that 1 and 2 5/10, and I could get the 10 times 10, and I'm at 25. So 10 grapefruits is in relationship to 25 oranges. Then I can take half of that and get 5 grapefruits to 12 and a half, or 12 and 5/10 oranges. So it works perfectly fine. And then I could say, well, what if I had 100 grapefruit? What if I had 55 oranges? So you can look at those relationships. So I'm going to jump to the, you can work on these yourself if you want, but okay, if we have the 55 oranges, so I already know my relationship is 2 to 5. And so with the oranges, I have 5 there, 2 grapefruits, and I can take that 5 and then I can multiply it by 10, I get 50. And so now I can take those 2 relationships and compose those together, and now I have 20 grapefruit for the 50, 2 with the 5, and I now have 22, I need 22 grapefruit for 55 oranges. So this just, the 1, 2, 5, 10 table is wonderful in all these ways. So now, okay, how does that relate to algebra, to graphing? So now I can, the y and the x-axis, I'll put the grapefruit, it doesn't really matter for either of these two because they're not, one's not dependent on the other. Grapefruit on the x-axis, and then I'll put oranges on the y-axis, and now we can graph that out, 0 and 0. Then we can go over 1 grapefruit is 2.5 oranges, and I can do 2 grapefruit is related to 5, and now it shows that graph. I can also, if you look at y equals mx, so we're doing proportion versus, if you might be thinking slope, with the slope there, but the y equals mx plus b. We have no b right now because it's 0, 0. That's a whole nother discussion. Important to know though with kids, and so that's really 6th and 7th grade work here. And so now that means slope, or m, is equal to y over x, which is our oranges over our grapefruit, which would be 5 over 2, which is 2 and 5/10. But I would probably leave it as 5 halves because that's how we tend to think about slope when we're dealing with algebra. We keep it in that ratio, or in that, we'll end up later talking about how that's related to fractions. It's a different conversation. But what we've just talked about now is We have this huge problem with kids being able to understand multiplication, division, use it to problem solve, use it with whole numbers, decimals, fractions, percents, ratio, proportion, and then slope. We have this massive problem. So now this one tool, the ratio table, it's a flexible algorithm. There are rules for it to use it, but it still builds on kids' thinking and what they already know to build what they want to solve in the future here. And that allows you to build grade 3 knowledge all the way up through algebra. So, ratio table, very powerful. If you just want to check some of them out, all of our materials on our website, www.dmtinstitute.com. If you want access to our 3rd grade materials all the way through 6th grade that use the ratio table, great. We also have some practice activities. We have 7 of them. They have about 10 pages per to build up this knowledge from 3rd grade to 6th grade on Teacher Pay Teacher, so you can check that out as well. So please, if you like this DMT Insight, go ahead and follow us, like us, and please share this with others so this knowledge gets out there.